Here's our hardware setup for today's demo. Our microcloud is made up of 4 Raspberry Pi 4 with 8 GB RAM and 128 GB on a SD card. Our first step is going to be flashing the SD card, so let's get started. So let's search for Raspberry Pi and go to the install page. We're going to download the 2004 server image for 64 bits. And of course, ARM ARC. This is already downloaded on my computer, so I'm not going to download it again. And then we're going to use the DD tool to flash to the SD card. So let's open the terminal. We're going to set it to downloads. We're going to use the NXZ tool to extract it. This is going to take a fairly long time, so let's move forward. Now that we have extracted the image, we're gonna flash it to the SD card. So first, let's see where is the SD card. In my case, let's do that bigger. In my case, it's gonna be on the SDA because I am on a Raspberry Pi 400. So my main OS is the MMCBLK, and you can see SDA is the SD card. Let's use DD to flash the file. We're going to use block size of 4 megabytes. Sometimes you're going to need a lower value here. That's going to take longer though. But in our case, we can do that. And we're going to put the SD card's device as the output file. So in this case, SDA and not MMCBLK. Oops, sudo. Let's go. This is again going to take quite some time, so let's fast forward the video. So we want to prepare our SD card for use, and for that we're going to need to mount it. It's /dev SDA1 is the system boot, and SDA2 is the file system. Let's see, here we got the full file system there. We're going to first put our SSH public key there so we can log into the Raspberry Pi once it's powered on. And we're also going to want to change the host name so we can easily identify it. So first, let's uncomment this authorized keys file property in the daemon configuration so we can use a non-relative path. Here you see I've put /etc so you can access it from anywhere. It's not non-relative to the user. So you see that I've got everything into my authorized keys already. So I'm just going to copy it. It's going to be quicker and safer. So now we are able to log in remotely without even using a password. Even though the first time we're going to have to change it, it's going to work headless, completely headless. So as I said, I'm going to want to change the host name as well, because otherwise we're going to be confused on which node we are logged in. All right, gonna unmount this one, and yeah, there is a last configuration that we want to do, which is on the system boot partition, and this is to enable the memory C group so that microcates will be able to be fully functional on this microcloud. So that's a bit of a manual configuration. All of this could be automated and done a bit more easily, but let's say for the demo we want to show everything, so let's do that manually together. So I've put the SD card within the Raspberry Pi. I've turned it on. It's a power over Ethernet, so I just plugged in. I'm gonna SSH in the Raspberry Pi. You see I've got to change the password for the first time. Okay, so let's use a new one, and now we can SSH within the Raspberry Pi. Hey again, I've done a massive fast forward to the demo basically because I've just configured the 4 SD cards as we've done with the first one. And I've also configured a Ceph storage backend, which is a fully redundant networking storage. You don't have to do it. You can basically use any storage backend that LXD supports, which includes the local storage one, which is the easiest one. And that's really not important. The microcloud is fully modular. You can take the layers you want. If you only want the microcates one, you can only take only the microcates one. And here we're going to have LXD on top of LXD, we're going to have microcates. And it turns out that we're going to have Ceph storage, but that's really not important for the demo. So we're going to SSH into the first Raspberry Pi. There we're going to refresh the LXD snap to make sure it's the latest version. And then we're going to jump into LXD init. We're going to want to use clustering, of course. Let's keep the hostname, the IP, and no cluster yet. Password, of course, that's the password. And we don't want a local storage pool because, as I said, I'm using Ceph, but this is the part that's going to change maybe for you. And okay, Noma server, and we're going to want to use the Ethernet interface so that the DHCP, sorry, just uses your containers and VMs as if it were new computers in the network. So let's SSH into our second Raspberry Pi to configure it. Let's refresh the snap again and LXD init. We're going to use clustering, keep the hostname IP, join an existing cluster, yes. This is the IP of the first node to Raspberry Pi 1. And accept the fingerprint, put the password. We agree that we're going to lose any data, and that's basically it. Yeah, we have it. So let's see what's in the cluster, and 2 Raspberry Pis as expected. That's great. Let's do the 2 others. So to make it easier for us and to not have to SSH into one of the Raspberry Pis in order to manage the cluster, we're going to use one of the great features of LXD, which is a remote. We're going to add a remote here. So you see, we don't have any cluster at the moment. We're going to do a remote add using the host name or the IP of any nodes of the cluster. Let's just use the first one here, accept the fingerprint, and put the password. Great. So now you just have to switch to this remote you just added, and you can already list what's in the cluster. So we can see that we have our 4 Raspberry Pis there, and that's it. Now that you have a LXD cluster, you can basically create virtual machines and Linux containers. For the microcates installation, we're going to use Linux containers as we're following the tutorial that you can find on microcates.io. That's fairly easier and even more secure to use virtual machines. But on the other hand, the performances are going to be better with a Linux container. So in this case, we're going to need a profile for telling LXD to give special permissions to microcates, or to the microcates container in this case. And we're just going to download the one that you can find in the tutorial. Using X4 is going to work well with our Ceph installation. But if you used the local storage one, you might use the ZFS. All right, so let's launch the container. The first time it's going to take quite some time as it has to download the image from the servers and initialize it, but the second and the third containers are going to be much faster to create. Once it's started, we can exec the command sudo snap install microcates, and yeah, you see it's not ready then. So as you can see, it doesn't have an IP address, so we're going to have to wait for the container to come online to be able to run commands on it. And you see it's too early for operation. Let's wait some seconds. And that's it. So we can sudo snap install microcates. It's gonna have to download the core for the first time, the snap, and run all the hooks, which is gonna take quite some time. Once it's installed, I'm gonna enable DNS and storage, and let's just jump forward to microcates initialized. Because I'm gonna follow the tutorial here and copy this rc.local file for AppArmor configuration, which is again specific to this Linux containers setup. As you can see, microcates is now running. We can use the LXD exec command to go into microcates and get a config, and we can copy this config to our local kubectl configuration. So now we're able to execute commands within the cluster. So now we have our 3 microgates containers running, but as you can see, there is no high availability because they are not clustered together. So we're going to use the add node command to add new nodes to the cluster, to basically cluster them together. We're going to check if we can just ping it first, and yes, we can. So let's use the command to join the cluster. We're going to do the same with generating another token. We're going to do the same thing with the 3rd node. And we're going to wait for the cluster initialization to complete. And that's it. We can do a microgate status on any node to check if we indeed have the high availability enabled now that we have clustered all the 3 nodes together. Okay, it has to restart. So let's do wait ready this time. And yes, you can see it's running and it has high availability. So we can now move to deploying something on top of this microgates cluster. So before deploying anything onto the cluster, we're gonna need to check that our nodes are able to see each other. And for that, I've modified the etc host configuration to add each node host name and its IP. Okay, so now that this is done, I'm gonna head to the Docker Hub and to the Ubuntu account. There you can grab some image. We're going to go with Redis and jump to the end of the documentation where we have this Kubernetes part. We can just download the Redis conf and Redis deployment YAML that is provided to us. And we want to do a Redis cluster, so we're going to have to do a small modification in the redis.conf. This is the cluster-enabled line that we want to uncomment to make sure that clustering is enabled, and the line after it, that is the cluster config file, we want to make sure that this line is defined. The name doesn't matter, but nodes.conf is clearer maybe. And all right, now we are ready to deploy. So we're just going to copy paste this comment from the Ubuntu/Redis documentation to create a config map, which includes the redis.conf that we just edited. And we're going to apply the deployment. So this is going to create one pod. We can do the watch kubectl get all command to watch it being created in the cluster. You can see that it's already running. And that's the name of the pod that we will need to use later if we want to log into the pod and exec some command. We can do that with a kubectl exec with the interactive mode, and we are going to use the Redis CLI dash and that's it. Okay, I'm not going to do the password the first time just for you to see what's happening. So you can see in the redis.conf that there is a require pass filled with my password, so we can just use my password as a password. And you see that the cluster is in the failed state. That's because we only have one node at the moment, so not really any cluster. We're going to scale the deployment to add more nodes to the cluster. And that's just very easy. kubectl scale, deployment, Redis deployment, and we want to set the number of replicas to 6. So we're going to configure to have three master nodes and 3 slave nodes. So again, we can watch the pods being created on the cluster. That's pretty quick. All right, so now we want to cluster these nodes together. So we can list all the pods that are related or labeled with this application Redis tag. We're gonna want to list them with or by their app IP, their pod IP, so that we can use this IP address in the Redis CLI command to cluster all the nodes together. So we're gonna use output JSON path just to have it already formatted the way we need it. And then we're going to execute the command to cluster them. So that's, we need a password again, and that's a bit complicated command, but you have -- cluster create to create a cluster, and dash dash cluster replicas to set how many replica for each master you want. So here we want 3 masters and 3 slaves. So we're going to set run replica only, and we can paste all the IPs and ports there. You can see that the cluster is being created, and that's it. So we can run again the command that was showing the cluster information. See, the same command that was failed before is now in an OK status. So we have a fully functional, high available Redis cluster that is using LTS Docker images.